Hi everyone, this is the first part of 2.7 on absolute value functions. Just like we did with piecewise functions, we already talked about absolute value earlier, but today we're going to focus on the graphing. And the reason this is a two-part lesson is we're going to learn something called transformations, which is a very important topic you guys are going to learn to use a lot over the next few years. And I want to go slow and make sure you really understand it. So let's start with a quick review of what you already know about absolute value. Absolute value is a function that turns everything positive. So we said, if you have a number that's already positive, just leave it. The absolute value of 5 is 5. But if you have a negative number, it turns it positive. The absolute value of -7 is positive 7. Now, since we just finished talking about piecewise functions, I want you to realize that absolute value, technically speaking, is a piecewise function. So what we have right here, this here is our notation. The two little vertical lines like this mean absolute value. So absolute value of x equals, and then see you have your piecewise function. So right here, where I say if x is less than 0 is a negative number. So we're saying if x is a negative number, and you put a negative in front of it, that double negative turns positive. So this is the math way of saying we're going to turn that negative number positive. We're going to take that negative, we're going to put an extra negative in front of it. Negative of a negative number is positive. Now on the bottom, we say if x is greater than or equal to 0, it's fine, just leave it. X equals x. So that's the piecewise function, the mathematical way of saying what we said in words earlier. If x is a negative number, change the sign on it, make it positive. If x is a positive number or 0, just leave it. All right, now let's take a look at the graph. The graph of the absolute value of x is a perfect V shape like this. This is the graph of f of x equals the absolute value of x. Now what's really happening here, remember I said it's a piecewise function? Right here is where x equals 0, which means on the right side of that line is where x is greater than 0, and on the left side of that line is where x is less than 0. Well, what you have right here is the line y equals x. Now the blue one on the other side is y equals -x. So it matches with our piecewise function exactly. We said if x is positive, just leave it x. But then we also said if x is negative, we make it -x. So again, you get that perfect V-shaped graph, but it really matches with our piecewise functions that we talked about yesterday. All right, so now that you know what absolute value looks like, that perfect V-shaped graph, our main topic for this section is transformations. Now, to transform something means to change it. So we're going to take that V-shaped graph and we're going to change it. We might move it, we might make it skinnier or wider, we might flip it so it's an upside down V, but we're going to make changes to it, and we're going to make those changes by making changes to the equation itself. So that's what we mean when we say transformations. If I take that absolute value of x equation, f of x equals absolute value of x, and I change it, maybe I add a +2 or a ×5 or something like that, we want to know what changing the equation does to the graph. So our first transformation, and I think it's probably the easiest one, that's where we're starting this one, it's called a translation. Now a translation is just moving something. It's when you shift, in fact that's another very common word, I use that word a lot, so I say you shift the graph, or you move the graph. So we might take that little V-shaped graph and move it up or down, or left or right. But you want to know from the equation when to do that. And a translation or a shift happens when you add a number to the function. Now, which translation you do depends on whether the number is positive or negative and where it's being added. So let's start by adding a number outside the absolute value. So we have our f of x equals absolute value of x, and let's say I just put like a +10 on the end, or a -7, or something like that. That's going to take that V-shaped graph and it's going to shift it up or down. It shifts it up for a plus number, and it shifts it down for a minus number. So if I have, absolute value of x plus 10, it shifts it up 10 spots. If I have absolute value of x minus 7, it shifts it down 7 spots. So let's do a quick example here. Let's graph f of x equals absolute value of x plus 3. Now the key to doing this graph is to know that this is absolute value of x. That's the V-shaped graph that we just learned earlier today. Then this plus 3 means we are going to translate it or shift it up 3 spaces. And that's it. So let me start with a graph, a blank graph here. This will be our blank graph. And what I'm going to do, I'm going to start by just drawing absolute value of x. Absolute value of x, the point of the V is right here at the origin at 0, 0. And you have one line going up this way that cuts that quadrant right in half, and one line going this way, right down the middle, that cuts both quadrants exactly in half. So that was the same graph I just showed you. If I want to translate this graph up 3 spaces, I'm going to kind of focus on the point of the V. And I'm going to take that up 3. I'm going to count up 1, 2, 3 spots. I'm going to put a point right here. And what I'm going to do is I'm going to draw that exact same V shape, but starting at that point instead. And the purple graph is the answer. It was that simple. If the black graph is absolute value of x, which it is, the purple graph is absolute value of x plus 3. And if I change the plus 3 to a minus 3, we would just move it down instead of up. So by adding a number onto the end of our function or outside of the absolute value bars, it just takes the graph and shifts it up or down that many spaces. Okay, so let's say we add a number inside the absolute value. So like we have our absolute value of x. Let's say we make it a little bit wider and we put a plus 10 on the inside with the x, or a minus 7 or something like that. What that does is it shifts it right and left instead of up and down. Now, read very carefully here. I said it shifts the graph left for positive numbers and right for negative numbers. That's kind of backwards. When we did the up and down, it was just like any other, like plotting a point. If it's a positive number, you move up. If it's a negative number, you move down. Now, usually when you do x's, for positive numbers, you move to the right, and negative, you move to the left. But I said this is kind of backwards. For a positive number, like if we had an x plus 10, you would actually move 10 spots to the left. And if we had an x minus 7, you would move 7 spots to the right. So make sure you remember that. The shifting that goes sideways, left and right, it's kind of backwards. It's the opposite of what you'd expect. For a positive number, it's to the left, and for a negative, it's to the right. So for our example, let's graph g of x equals absolute value of x plus 3. So this time, it's still an absolute value, so it's still going to be that V-shaped graph. And I even did the same number. I did plus 3 again. But see, this time the plus 3 is on the inside of the absolute value instead of being on the outside, and that's very important. So when the plus 3 is on the inside, I know this is going to move my graph sideways. But then I have to be very careful here, because when you see plus 3, you might think 3 to the right. That's your initial instinct. But this is actually going to translate 3 spaces to the left. When you're shifting right and left, a plus shifts to the left. So let me start with the same picture I did before. This will be my blank graph here. And just to have a point of reference, here's regular absolute value of x. What I want to do then is I want to take that graph and shift it 3 spaces to the left. So I'm just going to focus on the point of the V again. I'm going to take that point from 0, 0 and go 1, 2, 3 spots to the left and mark a point right here. and then draw the V shape from there instead. So this time the light blue one is the answer. I took the black one and I shifted it 3 spots over to the left and it was right there. Okay, the last thing to do for today is to take a look at a question that maybe has both of them. So we did f of x, we did g of x, here's h of x. We have the absolute value of x minus 7, which is one translation, but then we also have a plus 5, which is another. Now notice, I didn't actually ask you to graph it this time. I asked you to describe the transformations. That means I actually want you to write me a sentence. Tell me what's happening. So I'm going to do that. I'm going to say, if I wanted to describe the transformations of h of x, I would say, let's start. You have to have something to transform before you can transform it. So let's start with the absolute value of x. Then, one at a time, I am going to translate it, or you can say shift it, and let's do one at a time. I'll do the plus 5 first. Doesn't matter which order you do them. Let's translate it 5 spaces up, and then I'll do the negative 7 second. That would be 7 spaces to the, now be careful here, this is the one that's backwards. A minus actually goes to the right. And that's our answer. I never asked you to graph it here. So, and make sure you're reading the directions carefully in the homework. Some of the questions ask you to graph it. If it does, graph it. Some of the questions say describe the transformations. If so, do what we did here. Just write me a sentence. But the idea is any number outside, like the plus 5 in red, that's always going to be a shift up or down. A plus 5 shifts up, a minus 5 shifts down. Any number inside the absolute value is always going to shift sideways. A minus 7 shifts to the right, and a plus 7 would shift to the left.